Welcome to Big Ideas 1.1, Parent Functions and Transformations. So remember, throughout these videos, you can pause at any time and jot things down in your notes. Also be aware that these examples are from Big Ideas, your textbook. So this is just me going over the examples. You can find them in your text online at bigideasmath.com. All right, so let's get started. First of all, we're going to just identify function families. So in algebra, we study many different types of functions. Here you have 4 functions, and they're parent functions. So we have constant, linear, absolute value, and quadratic. The parent function of a graph is the simplest form of a function. So the parent function is what you're seeing here of a constant function is just y equals 1. So that would just be a flat horizontal line. It does not have a slope. It's just a constant where y equals 1. Remember, f of x is our output or our y values. So we often just think of that as y equals. A linear function we're familiar with, f of x equals x, or y equals x, is the simplest form of a linear function. This line has a slope of 1 and a y-intercept of 0. Absolute value functions, y equals the absolute value of x, of course have to have absolute value bars. Remember, the absolute value of a number is the distance that it is from 0 on a number line. So the absolute value of 3 is 3 because 3 is 3 units from 0 on a number line. The absolute value of -3 is also 3 because -3 is 3 units from 0 on a number line. So absolute value you can think of as a distance from 0. So that explains this V shape. The absolute value of -3 would be +3. So those negative values get kicked up. And lastly, we have a quadratic function. Y equals x squared is the simplest form of a quadratic function you can have. This is a U shape or a parabola. This shape comes from the squared, so a quadratic has to have a x squared in it. 0 squared is 0, 1 squared is 1, 2 squared is 4. -2 squared is also 4, so you can see that U shape forming. All right, these parent functions also have a domain and a range. Remember, the domain are the x values and the range are the y values. So all of these graphs the blue line goes forever left and right. So all of the x values are included in all of those. So your domain or your x values are all real numbers. The range for this constant function, well, those are your y values. So in this case, y is always 1. So it's just y equals 1. Here, you have y values forever going up and down. So it, again, is all real numbers. And these two, the blue graph only goes up from 0. So there are no negative y values in each function. So we say the range is y is greater than or equal to 0 in both of them. So to identify functions, we just look at the shape of the graph. In this case, we have a V shape. So to identify this, I would say, oh, that's an absolute value function. And I know this because of the V shape. I also know this because the equation has an absolute value bars in it. Now, this is not as simple as our parent function. It's been multiplied by 2 and had a 1 added to it. So that is a transformation or a change of a graph, and we'll talk about transformations as we move on here. Okay, this next one is this U shape, so I can see from my examples here that that is quadratic. And I can also see from the equation that if you took this quantity x minus 3 and squared it, you would end up with an x being squared. So it has that x squared. This is not as simple as our parent function. It has been widened and moved to the right. So it has been transformed, which we'll get into next. All right, a transformation, again, is a change. So it changes the size, shape, position, and orientation of a graph. We're gonna start with translations. That's the first transformation we'll see. A translation is when a graph is shifted horizontally, so left or right, or vertically, up and down. It does not change the shape or size or orientation of the graph. So a translation is a shift horizontally or vertically. All right, so let's look at an example. G of x equals x minus 4. So in our picture here, we have our parent function, f of x equals x, which remember is the simplest form of a linear function you can have. And then we have our new function, g of x equals x minus 4, which is shown here. And as you can see, our line has simply been shifted down 4 units. So that is a translation. Now you should remember from Algebra 1, y equals mx plus b. So the m, remember, is our slope, how steep the line is, or the rise over the run. And the b is the y-intercept, which is at 0, b. So where x is 0, y is b. So in our parent function, let's write that here, y equals x is our simplest form. Really, there's an invisible 1 there in front of the x, and there's no b, so I could add 0. So our slope is 1, and our y-intercept, where x is 0, our b value is also 0, 0, 0. So you can see it crosses here at 0, 0, rise 1, run 1, rise 1, run 1. All right, so in our new function, all we have done is changed our b value, where x is 0, y is negative 4. So we've changed our y-intercept to 0, negative 4. We've shifted our graph down 4. That is called a vertical translation.